are quite restrictive in what they put in the spec, and they give guidelines to lunatics like me about what I can and what I can't put into the spec. The spec is not the best thing in the world. The best thing in the world for you guys is to look at past exam papers and use that resource. You'll find that really handy to use as a resource. You get lots and lots of material from that, and you can get those on the AQA website. And if you email me, I will, or you can use, and I can provide you with anything that I'm missing, for example. And there's a company called Exam Pro. An Exam Pro for GCSE and for A-Level produce past exam paper questions with mark schemes and with examiner's report, and that again is very up to date. You can use that as a resource as well, and that's my email, by the way. It's not exactly a hard one to remember. Yeah, Exam Pro's okay. I'm involved with Exam Pro, and I'm the one that updates it every year. If you're really struggling, you might want to try and get hold of legacy exam questions. That's the specification before the current one, because the topic areas like the hearts and blood and the lungs haven't changed in the last half dozen years or so. They're still exactly the same. But I do appreciate what you're saying, Kelly, and I do understand your I'm going to use the right word here, your problems. Can I use that as the right word? And your annoyance is a better word, maybe. Your annoyance that you taught as per the spec and then found possibly a question you were surprised to get, and that's not good. But I know what AQA are going to say. The spec says transport of blood gases. Underline the word gases and say that implies more than one. I can't think of another one. I don't suppose they're going to ask a question on the transport of nitrogen. I'm not being facetious. I'm just trying to answer it how AQA will answer it if you wrote in and complained to them. Okay, let's move on. Yeah, I'm not, I work for AQA. I have worked for AQA for 20 odd years, but I'm not AQA. But I know how they will speak and what they'll do and that sort of question. You're welcome, guys. Okay, let's move on and keep the show on the road. We're looking at Fed 3, the A2 part of the course. Okay, again, looking at content and suggestions and everything else we can think of. I think if you're teaching physiology, you should teach energy systems first, day one, energy systems. And I think it just works better if you teach aerobic systems first. I think getting the students to understand what's involved in aerobic processes is relatively important, because I think energy systems underpins everything else. If you understand energy systems, then fast and slow twitch muscle fibers become very, very easy. If you understand energy, then lactate threshold and VO2 max become relatively easy. So I always hit energy systems on day one. I hit them with aerobic systems, use the KISS principle, keep it simple, and use past mark schemes to detail the content. I do not deliver anything that I don't think will get them credit in the exam. So we never, it's slightly different to, again, to OCR. The AQA spec mark schemes is slightly more simplistic than the OCR version. So for example, there's no credit given in the AQA spec, in the mark schemes I've seen so far, for knowing about the enzymes involved, for knowing, for example, about lactate dehydrogenase and that sort of thing. It's not there. So therefore, because it's not in the mark scheme, I won't teach it. I always work on the basic premise that if they can remember images better than they can remember words, let's teach them through images. So my students spend whatever time it takes me to deliver energy systems, and a few months after that, being regularly asked to draw the diagram of the energy systems. And they produce a diagram. And that diagram then becomes a simplistic outline of the processes involved, and they can use it as an aide-memoire during the exam. And again, just to hopefully be helpful for you guys, I've included that diagram in a simplistic form, not in as much detail as I'd probably use in their notes. It doesn't mention electron transport chain, doesn't mention the detail of what's going on in Krebs cycle, for example, but that's in one of the materials you're going to get as well on the thing. And it's very much an oversimplified diagram, but it helps them to understand what's going on. You also need to be aware, if you're not used to it, in the exam, the questions invariably ask about the main system being used. It's to stop people just rote learning all the systems off by heart. For example, we could ask a question about Mo Farah running a half marathon or whatever he might be running. And you get, if you do that without this guideline and this bullet point here, the student could then put, oh, there's three systems. There's the phosphocreatine system, where stored phosphocreatine in muscles can be broken down, etc., etc. Full stop. There's also the anaerobic system, where glucose can be broken down through glycolysis, and the pyruvates then converted into lactic acid, and you get fatigue. But you do get some ATP resynthesized. And there's also the aerobic system that works like this. And they write that down as an answer, but they're going to get 4 marks for every energy system question. So to stop that, we tell everybody that the questions always ask for the main system. And if they don't identify the main system, ready for the kick in the teeth, they get 0. If they don't identify the main system, they haven't answered the question. Therefore, they get 0. So even though the Mo Farah question might elicit the phosphocreatine system, might elicit the lactic acid system, and then might elicit loads and loads of valid points about the aerobic system, if they haven't told us that the aerobic system is the main system being used, they get 0. Please bear that in mind if you're the physiologist delivering energy systems. I like to use lactate threshold and VO2 max as means of measuring performance. I'll give you another outlook on that in a couple of slides' time. And epoch, I actually take that diagram on the 3rd bullet point, which shows the simplistic diagram of energy systems being used. I then use the reverse of part of that diagram to show what epoch's all about. Lactic acid being converted back into pyruvic acid, which can then be used for ATP resynthesis through Krebs cycle electron transfer chain, or in certain parts of the body, the pyruvic acid can be converted back into glucose, part of the liver and the Cori cycle and all that rubbish. Okay, so that sort of idea is how I deliver the theory and what's involved in that. In terms of practical delivery, I'm a big fan of being in the sports or doing it as a practical, as long as you can maintain their attention. So you need maybe a whiteboard that's working, and maybe start off with walking around, what we always do, walk around and say, okay, you're actually producing or requiring energy in your muscles. Where's it coming from? It's coming from food. And then start saying it's more specific. It's not actually food. It's going to primarily be carbohydrates and fats, primarily in these sorts of forms, and build it up in stages. Works quite well. You could also then start throwing in more and more information. So for example, where is this food that we're talking about? Where's it kept in your body? Be more specific about what type of food it is. Talk about the gases involved, the oxygen and the carbon dioxide. Maybe the stuff about ATP resynthesis and glycolysis and the mitochondria and electron transport chain. That's not going to work too well if they're walking around in circles. They need that to be in a classroom and on a whiteboard somewhere. So a bit more detail, as far as I can see, that 4th bullet point down needs to be classroom based. But all the time, diagrams, the same diagram all the time. Whatever you want to structure this diagram, get them to use the same diagram all the time. Get them to rote learn the diagram. Talking about the different intensity and the difference between an elite performer and a non-fit performer. The non-fit performer who very quickly starts to struggle. Even some people just walking around because of inability to get sufficient oxygen to the mitochondria. Whereas elite performers can carry on for literally hours at a time, walking, jogging, running almost, and without any problems. Other centers, not me, you now know what I'm like, other centers use role play quite extensively, and it works very, very well. The idea of breakdown and picking up ATP and picking up oxygen